Alright, welcome to Braun Engineering. My name's Alan. In this video we're going to make a test part on the APSX Nano Swiss Lathe. The part we'll be making is this little dude right here. And this one's made out of 316 stainless steel, but for the sake of brevity we're going to make it out of 6061. As you can see, a lot of different features on this part. Try to get that in focus for you. And we're going to cut all those features in one holding, which will give a really good opportunity to illustrate the machining options available on the APSX Nano Swiss. So we'll start off in a Fusion 360 session, and then we'll go out to the shop and make some chips. We'll see you there. Here's our part in Fusion 360. As you can see, a fair bit of features. So taking a look here, we have a through hole as well as a slot milled in the face. We have a turn diameter and a groove. Then we have a hex pattern, a thread relief on both sides of a threaded section, which is a 1032 thread. And then I chose to add this little boss on the back there to make programming a little bit easier for myself. Now the way we have this part set up is the axis, the longitudinal axis of the part is coincident to the front plane, and our X and Y axes are set up like this. We have our Y axis positive away, and then our X axis positive pointing straight down. This mimics how the Nano Swiss is set up, so this is how I like to do my programming for it. We're going to be starting with 1/2 inch stock, and our first cycle is our roughing cycle, and we're going to remove some of the material from the front of the part and then do the final features. So the tool we're going to be using is a PH horn insert. You can use these PH horn inserts, the S274 line of inserts from PH horn with the APSX brand tool holders. This insert is a 3mm wide groove insert. Here it is right here, the product code. And what I really like about this tool is the grind that they have that helps guide the chip out and away from the work. It just makes handling the chips much easier. And we're going to be running this tool at 1200 RPM and 2.5 inches per minute. So for roughing, for profile roughing, this is a pretty conservative feed rate. You can actually use 2.5 inches per minute for doing full width grooving into aluminum. If you're just going to be doing profiling, you can run this up to 4 inches per minute, sometimes even up to 5. Just be very careful if you start pushing the feed rate, because if you stall the motor on the Nano Swiss, you will lose your X offsets. They'll skew by about 10 thousandths. So definitely want to remove material quickly, but need to be conscientious about not stalling out the motor. Since we have our material roughed off, we're going to come in and do our finished groove. We're going to do this with another PH horn insert, running at 1200 RPM and a much slower feed rate, 1.5 thou per revolution feed. This insert is a 40 thousandths wide insert. It actually comes standard from APSX when you order the Nano Swiss, so you should already have it on hand if you buy the machine. Here's the designation right here on their product page. Now you'll notice this one doesn't have that angular grind on it, so the chips are just going to want to curl straight back towards the part. So I would recommend just using this for finished grooves. Okay, once we have our groove done, we're going to come in and center drill the front of the part. We're just using a 3/16 inch center drill, just going deep enough to make sure that our drill doesn't drift. Coming in with the drill, it's a 60 thousandths, around 1/16 of an inch drill. Very delicate, so I want to make sure we give it a good start. You'll notice that we're not going all the way through the part just yet. We're going to leave the material towards the back of the part to help support it. We're going to be running this drill at 1400 RPM and about 2.5 inches per minute plunge at a 50 thousandths peck. Now, one thing to note is that when you do drilling for the Nano Swiss, the post-processor is going to assume that you're doing radial drilling with the live tools. So you'll need to go into the part or the G code file once it's posted and edit it so that it does axial drilling instead of radial drilling, and I'll show you how to do that. Now once we have our hole drilled, we'll come in and rough off some more material, again with that 3mm wide insert, and then we're going to do our hex pattern. So coming in here with a 1/4 inch 2-flute end mill, and we're going to run that end mill at 6,000 RPM and 3 inches per minute feed. Now we're not going to be doing any finish cuts, we're just going in there and taking it all in one pass. We're going to use the pattern function in Fusion to get all 6 sides. Then once we have that completed, there's a pass-through code here, G0C0, which just sends the C-axis, the indexing axis, back to 0. Once that's done, we're going to come in and do the slot on the front of the part. And we're going to do this in 2 passes, a roughing and a finish pass. And we'll be using this tool from KEO, which is a 3/64 inch keyway cutter. The trick with finding the correct tool to use for this feature was finding one that has a 1/4 inch shank, because that is the largest tool shank you can hold on the Nano Swiss. So very, very fortunate to find this tool in the correct geometry and on Granger. Been running it pretty slowly. I really don't want to have to buy another one of these. They're a little bit expensive, as you can see. So staying conservative on our speeds and feeds, we're running at 6,000 RPM and 2 inches per minute feed. And once we have our slot milled, we're going to come in and do some finish turning. I chose to wait to do the finish turning until all these features were done, just so I didn't kick up some burrs. When you get to the hex section, it has a tendency to throw the burr back over with the mill, so it's better to come in with a turning tool afterward and clean it up. The tool we're going to be using for this one is a insert from WizCut, J15 ERV12-2. And here's their product page. So this is a finish and copy turning profiling insert. It's got a big relief on the back so that you can get into some tricky spots on some parts and do a nice finish pass. You will need to buy the WizCut tool holder that fits this insert and modify it by bringing the shake down to 12mm and drilling 2 mounting holes. Actually, I believe the shank already was 12mm, so you don't have to modify it from 1/2 inch, if I remember correctly. But drilling the holes will be a bit tricky because those tool shanks tend to be hardened. Okay, and the feeds and speeds for this insert. Max RPM for the Nano Swiss is 1800 RPM, so we're going to max out on that, and then doing 1,500 feet per rev. I chose to break this up into 2 sections, just doing the in front of the slot and then behind the slot, or the groove rather, to get finished. Now once those are done, we're going to come in and rough out the back of the part, again using that same roughing cycle. And then once that's completed, we're going to come back in with that 1mm wide groove tool and clear out the thread relief. And then after that, we're set up to do our threading cycle. The tool I'm using for that is a Micro 100 ER-8. Forgive the model, I just did it that way so that it didn't collide and give you a bad image of how the part comes out. There is clearance. This part can be found, or this tool can be found on the Micro 100 website. It's the ER-8 down here. These are really great inexpensive tools, the Micro 100 braced carbide line. They're great for the Nano Swiss because the tool shanks aren't hardened. They are 1/2 inch, so you will need to modify them down to 12mm for them to fit on the tool gang. But again, they're not hardened, so milling them and then drilling and tapping some 1/4-20 holes into them is very simple, and it won't compromise anything about the holder itself. You also will need to shorten these as well. So having an unhardened tool shank is advantageous for many reasons. All right, the feeds and speeds for that thread tool, we're going to be using just 300 RPM. And I think their depth of cut, what are we doing? There's the thread pitch for the 1032 thread. Let's see, we're not taking much. Let's see. Well, anyways, I think we did it in 4 step downs. That will leave a little bit of a burr on the thread because it's not a full profile insert, so you can come back in there with a die and clean it up very easily. Now once the thread's completed, then we're going to come back in with our drill, take it all the way to depth through the part, making sure to break through a little bit. From there, there's a pass-through code, and this is an M1 and an M9, and that is an optional stop and turn the coolant off. So this is the pass-through code that I like to do after all of my cycles are finished except for the parting, so that I can come back and catch the part. Now for the parting cycle, we're going to be using, we're going to be using a Glanz brand tool holder, and I'll show you that. It was just one of the only tool holders I could find that was 12 millimeter and could easily mount into the gang with this style of clamping screw onto the insert, and it's using this style, the GTR style inserts, and I like using the one with the I believe it's about an 8-degree relief on it. This leaves just a little bit less of a burr on the back of the part. You can knock it off very easily. You will have to run the machine very slow though, as you can see, running at 1400 RPM, but only a ½ inch per minute. And I like to do my radii here just nice and tight. Be very careful if you do it this way. Make sure that you clear enough space behind the parting. That's why I had that extra boss on the back of the part, to give myself some clearance for the tool. Instead of having to come all the way to the ½ inch diameter of the stock, you can bring your parting blade in right at the model diameter and just plunge from there. It'll save you a little bit on your cycle time. Again, just be very careful. Once that's completed, got a couple manual pass-through codes. This just retracts that parting tool out to clear the stock, so 0.6 inches. And then from here, this is my end of cycle / prepping for the next part pass-through. So this changes back to tool 1, and it will cut a little bit of the material just to get a clean face. And then from there, it's going to send the tool gang all the way to the farthest -Y position, so you can blow it off with your air gun, clear out any chips before you rehome the machine, and then press cycle start to do your next part. Okay, we are ready to post-process our session using the APSX supplied Nano Swiss post-processor. Create a new file. And if you want to have your G-code formatted and color-coded like this, just head into extensions, search for NC G-code, and install that, and it'll do it automatically for you. Okay, so a couple things to note. First of all, if you look at our first roughing toolpath, this line will need to be changed. The reason why is because we ended the cycle at a far -Y to clear the chips, and if you allow it to interpolate, move the X and Y axis at the same time, you'll end up crashing your parting blade into your stock. So to avoid that from happening, what we'll do is we'll put our Y0 first, which will send it there to Y0 before heading to the X diameter position. So after that, we'll need to head into our drilling section, and make some modifications. So this code M101, that is for the indexing setup for using the live tooling. You'll need to modify that to M102. And this $sign and 1 is referring to the live tool spindle, so we will need to delete that section. And then also anywhere you see a C call, an indexing position, you'll need to delete that. So take that out, and that's for the center drill, and then we'll actually go into our drill op and do the same thing, delete the live spindle call out and the C position. And after that, you should be good to go. Well, that's going to do it for this episode. I know we covered a lot of ground here, so if you have any questions, feel free to put them in the comments below. Please like and subscribe, and we'll see you on the next video. Cheers.